Hello, hello, and welcome to a little video about calculating trigonometric ratios when we're given some side lengths. So let's take a look at this first problem. It says if cosine of theta is 5/13, find sine of theta. Well, yesterday, or the previous lesson, we learned that cosine of theta is adjacent over hypotenuse, so cot TOA. So we know that adjacent is 5 and hypotenuse is 13. That's pretty nice. I'm a visual person. Let's draw a triangle. It'll be helpful for us to solve too. You know, another diagram won't hurt. Probably will help. Okay. So I know it's not perfect, but that's okay. This is our right angle. I'm going to label this side as H for hypotenuse. Now, it doesn't matter where I put my theta. Today I feel like putting my theta right here, because I don't know which one of these angles we're talking about. So I'm just going to give it here. Okay. Now, if I put theta here, then this side right there, that is my opposite side, which means this is my adjacent side. This is great. Check it out. I know that my adjacent side is 5. So this side right here is 5. I also have that my hypotenuse is 13. So 13. Okay, so we drew a diagram. Let's find the missing side. We can find the missing side using the Pythagorean theorem, since this is a right triangle. Let's call this side B. Doesn't really matter. Okay, so we have 5 squared plus b squared equals 13 squared. Let's solve it. So that's 25 plus b squared equals 169. Subtract 25 from both sides. B squared equals 144. Let's square root both sides. Remember, this is a triangle, like a real thing, so we cannot have a negative side measure. So b is 12. Our opposite side, over here, instead of a b, I'm going to write 12. So now I can finally find sine of theta. Let's do it. Sine of theta is opposite over hypotenuse, so 12 over 13. So 12/13 is my answer. Alright, let's try another. Once again, like that other triangle, I'm going to write down what we know about tangent. So the other day we learned that tangent is SOHCAHTOA, so opposite over adjacent. So we actually know 2 of the sides. Let's draw our triangle so you see what I mean. I'm even having a hard time imagining it. I just need to see that triangle. It's not perfect, but that's okay. I'm going to say this is a right angle, which means this is my hypotenuse, right across from it. I feel like putting theta here, and again, it doesn't matter. It's one of the angles. It's not the right angle. So it's either this one or that one. We don't have enough information to say it's wrong to choose either the top or the bottom. Okay. Let's label our opposite side. Oh, and then our adjacent side. Okay, so what do we know? We know that our opposite side is 4. Okay, so this is 4. O is 4. We also know that adjacent is 3. That's 3. Okay, well, this is unknown side C. C is always our hypotenuse. Okay, let's find what that measure is. So we have 4 squared plus 3 squared equals c squared. So that's 12 plus 9. Did I just write? Oh my goodness. Oh my goodness. It's 6. What in the world? And now it's freaking out on me. Oh no. Okay, let's control Z. Something went wrong in my brain, and then the computer was like, no, Miss Gumin, I don't like that. Yeah, I know. 4 squared is 16. 16, I'm sorry. 12? Oh, I must have seen the 4 and the 3. Okay, 16 plus 9 is 25. This is a triangle, which means it's a real thing. We cannot have negative measures. So C is 5. Okay, so this missing side, instead of calling it C, I can now label it with a 5. And I would like to find cosine of theta. Cosine of theta. Cosine is so adjacent over hypotenuse. So our hypotenuse we found was 5, and what was our adjacent? 3. 3 over 5. This is our answer, 3/5. Okay, and that's about it. If you have any questions, please let me know. Otherwise, have a wonderful, whatever time of day it is for you. Bye!